Good day everyone. My name is Tobilid of BSECE 3A, and for this video, I am going to demonstrate the program that I created that will display an animation on my 8x8 dot matrix display. Okay, let's go to our NVM site. Our objective is to demonstrate the 8x8 dot matrix LED display application using a microcontroller. So our task is to number 1, create a scrolling effect that will display your full name continuously on your 8x8 dot matrix display. So scrolling direction would be from right to left. Number 2, use the same pin assignments that were used in our laboratory experiments procedures. Number 3, create a demonstration video, submit the link of your video uploaded on YouTube. And lastly, number 4, also submit the source code as format your underscore surname.eno file. For this task, we're gonna be needing an Arduino Uno R3, jumper wires, specifically male to female, or if you don't have, you can use female to female and connect another set of jumper wires, which is male to male, so you can connect it to our microcontroller. So it should look something like this. And we are instructed to use a power supply or battery, so for that, we will also need a 9 volts battery, and it's snap. Also, do not forget our USB cable. And last but not the least, we need a 8x8 dot matrix LED with a MAX 7219 driver. Okay, so what you are seeing right now is our schematic diagram. You see that our matrix is made up of 64 LEDs. Because I cannot see any electronic simulator that has a LED dot matrix with a MAX 7219 driver, I have manually wired up the connection of these two in FritzSync as you see. So if you have a 8x8 matrix alone, you would see that in the back, it only has a total of 16 pins. So multiplexing was used to reduce the number of pins needed to drive an LED display. So take a closer look. Moving forward, this is how our connections as instructed. So the connections are simple. No soldering required, and we only need to connect 5 wires. So first is VCC. VCC goes to the 5 volts pin of our Arduino, and this is the purple wire. Second is ground. Ground connects to the ground pin of our Arduino, of course. DIN or serial data input goes to digital pin 12, so that is the red jumper wire. Next is CS or chip select input goes to digital pin 11 of our Arduino. And lastly, clock or serial clock input goes to pin number 10. So let us see how I have connected these. Alright, let's go to the software side of my task. Let us first set up the library. So please go back to your NVM site, go to task number 5, and download the Pixel to Matrix generator and the LED control library folder. I think this is easy because Pixel to Matrix generator is a small software that will produce the data for each byte you create. And this LED control will be an added feature. So let me show you a demo. Let us go to our Arduino IDE, go to Sketch, and include library. So please choose Add Zip Library and try to find where did you store that downloaded data. So mine, I have stored it in here. This is. So you just click open and your IDE will automatically recognize that library. Alright, so let's go to my code. This is my code. As usual, we have declared the pins that we have connected. Then here, I have created byte arrays that contain the data for each frame, or graphics that you will see later on in the video demonstration. Okay, let me show you a demo. The first byte is a graphic of a straight line in the first letter of my name, and that is letter K. So just select the boxes forming a straight line starting from the right. Click generate and copy these values and paste it in our byte arrays. Now that we have created this byte, all we need to do is just to call them in our void loop and just go like that. It's simple. So my name in a scrolling effect has a total of 112 frames, including the space that I have provided because I thought it would not look good if I won't have a clear matrix before my last name scrolls in. And this line here creates the LED control object that's used to interface with our LED driver by providing the digital input clock in the chip signal pins, as well as specifying the number of devices. Next, you see the LED driver will be in a shutdown state when we first power on. So we need to tell it to wake up, and this is what the first line does. Lastly, Lastly, we clear the display of any possible values. In the void loop, I think this is simple. This is where we display our byte arrays. All we have to do is call the print byte, and by the way, I have put a clear display right after my first name was done scrolling, representing a space before my last name starts appearing, and you can find the clear display byte frame number 43 with a delay of 75 milliseconds. So scrolling on, and we have used the method setRow because what this does is simply apply the byte horizontally as opposed to vertically. It is just a simple 90-degree rotation. So let's jump to the exciting part. We will be demonstrating its functionality. Please connect your cable on the Arduino and your laptop. So when it is successfully connected, it will produce this sound. So go back to your IDE, just click upload, and wait while it is compiling. Okay, there it is. As you see, the matrix is working fine. So let me turn off the lights. You see the LED is very bright and the result is really impressive. So that's all for this task. Goodbye and thank you. But we are not done yet. So, as instructed, we need to use an external power supply. So we have our 9 volts battery and a snap connected. So just insert this in the barrel jack of your Arduino and voila.